let's talk about completing the square. Before we can do that, we need to talk about what a perfect square trinomial is. A perfect square trinomial can be described like this. If I put x plus 4 squared, that can be expanded to be x squared plus 8x plus 16. Do you know how I did that? Well, let's try another one and see if you can pick up on it. What about x plus 3? That would just be x squared plus 6x plus 9. Do you see it yet? Let's try one more. X minus 5 squared would be x squared minus 10x plus 25. If you haven't picked up on it already, this number in the front's magic. In those parentheses, if I take that number and add it to itself, so 4 plus 4, I get this positive 8 over here. And if I do 4 times 4, I get this 16. Let's take a look at the second one. My magic number was plus 3. 3 plus 3 is 6, and 3 times 3 is 9. And then when the negative is thrown in, it just gets mixed into everything else just like the others did. Negative 5 plus negative 5 is negative 10. Negative 5 times negative 5 is positive 25. So this is really helpful, right? Let's see if we can mix it up a bit. What if I was to tell you it was x minus 6 squared here, but over here I decided to only give you that minus 12x? Could you tell me what the last term in that trinomial would be? The one that belongs right here? If you said plus 36, or you're right. And notice that last number is always going to be positive, because a positive times a positive is a positive, and a negative times a negative is a positive. Now, what if I was to really mix it up on you? What if I was to say, I'm not going to give you the magic number, and I'm just going to give you, let's see, why don't we do plus 18x over here? So I'm not going to give you the number in the parenthesis, and I'm not going to give you the number in the end over here. Could you fill it in? I'm sure you could at this point, right? If I take 18 and cut it in half, that gives me my magic number of plus 9. And 9 times 9 is 81. This is all completing the square is. It's making that perfect square trinomial so that we can factor into this binomial you see on the left-hand side. So let's take a look at an example. This question is from the June 2022 Regents, and it asks us to determine the exact values of this expression, or I should say this equation, by completing the square. Now, exact values just means that we're not going to round any numbers, so we're not putting anything into our calculator here. So if I was to start by just writing down this expression, x squared minus 8x minus 5 equals 0, you might start by saying that that is not a perfect square trinomial. And I agree with you. That 8 and that 5, they just don't talk to each other. So we're going to get rid of that 5. We're going to add it to the other side just to get it out of the way. And we are going to be left with x squared minus 8x equals 5. So I want to know what number can I put here that it'll make a beautiful perfect square trinomial. So think, if I had that 8 in the middle, then that means my magic number must have been minus 4. And minus 4 times minus 4 is going to give me a positive 16. So that means that I added 16 to this side. But I can't just add 16 to one side of an equation, otherwise it would remain unbalanced. So I'm going to add that 16 to the other side as well, just to make sure that I'm keeping everything in line. My equation is remaining balanced. All right, now the whole point of making this beautiful perfect square trinomial is now I can write it as a binomial squared. What was that magic number? That's right, it was x minus 4. So now I have x minus 4 squared equals, and now I'm going to simplify the other side too. So this guy over here became this binomial, right, using my magic number, and these two together, 5 plus 16, that's just 21. Okay, now I have an equation that I can solve for x. So it wants me to find the exact values of x. So I'm going to solve this equation. If I take a look at the left-hand side, you'll notice that I have an expression squared. So I can take the square root of this left side, but again, whatever I do to one side, I must do to the other. Now, taking the square root and squaring a number are inverse operations, which means on this side, I'm just left with x minus 4, which is beautiful. They undo each other perfectly. But on the right-hand side, I need to remember that it's plus or minus the square root of 21 I'm left with. Okay, so you always get a plus or a minus in front of that radical when it's in an equation. So I don't have to do anything with that radical because there is no square root of 21. It's not a perfect square, and it's actually not simplifiable. There's no perfect square that fits inside of 21. So all I have to do is get that x by itself. So again, on the side of the x is that 4. I'm going to do inverse operations. I'm going to add that 4 to both sides. And all I need to remember is that you can't add a 4 to a rad 21. So over here, I'm left with just x. And on this side, I get 4 plus or minus rad 21. We like to put our whole numbers or our numbers in front of the radicals, so this would be a perfect answer. I would say x is equal to 4 plus or minus rad 21. Could you write them as two equations, 4 plus rad 21 and 4 minus rad 21? Of course you could. But the one thing you don't want to do is you don't want to put it into your calculator. And again, that's because in the instructions, it said explicitly the exact values of x. We've solved this problem by completing the square.